So good morning all. Welcome to SAKALAVIDYA YouTube channel. I hope everybody joining now. Okay, Swati Singh, Mahindra, Balu, Akshay Reddy. Uh, Next we have Naveen, Lingam Steshwani, Swati, Sadvika, Vaishnavi, Prudvi, Ishwaradi, Prasanna, Balu, Akilaki. Okay, Gandham, Vaibhav, Viprakash, right, Sekuntala, Kartikeya. Okay. Good morning all. Good morning. Vinoda. Kodala Kalyani. Okay. So in the last session actually we have discussed how to find out the domain of the functions, different functions. Today we will solve. Suma, welcome. Dishu, Sanja, Sudham Reddy. Okay. Hi, welcome. So now today we discuss the problems. But in problems also some concepts as well as the problems let us discuss because yesterday we have discussed very lengthy session on only introduction part. So today I planned let me concentrate on the problems itself only, but because the functions are very important chapter, but it's not hard. Don't feel it's typical chapter, it's not difficult, so easy. So it will be so easy, don't worry, but it will be useful for all the chapters. So that's why we need to concentrate on more, but after that so other topics will be completed as fast as. Okay. Now let us start the problem number 48. I think so, the problem number 48. And moreover, actually, those who are preparing for advanced supplementary for Andhra Pradesh, today or tomorrow, even TS results may be announced. So those who are going to appear for advanced supplementary examination, I don't say supplementary examinations because always we should be very positive. Everybody needs to pass. I don't even mention that word also, supplementary word, that you say advanced supplementary or betterment examination. Better you say betterment examination. Those who are appearing for betterment examinations, already once again already I have uploaded more than 600 to 750 videos. They are available. If you go through them, definitely you will get 75 marks. Okay, so you can suggest to your juniors, your respective colleges, and okay, you share your social media through Facebook, through WhatsApp, because I already told you you're all our family members, and once again you are the volunteers of our SAKALAVIDYA YouTube channel. And moreover, I know my mission is actually to give the free education to all the children. Understood now? That's why I started. I don't this channel cannot be we won't any make into the paid channel. It will be free channel itself only. I hope you will understand our mission, and this mission should be continued. To continue this one, your cooperation is actually required. Okay. Already we have Gudivada Bhargav that are available, tricks and tips. You go to the videos. Right. This is the actually regular session. Thank you. Functions part 7. Part 7. Yes, correct, Balu. Question number 48. Question number 48. the domain of the domain of the domain of f of x equals to x plus 1 root over x square minus 5x plus 6 is, this is the question. Okay, first option r minus 2 comma 3, second option open 3 to infinity, third option minus infinity to infinity, that means real number system, fourth option is minus infinity to 2 open union open 3 to infinity. This is the question. Right, let us see. The domain of f of x equals to x plus 1 upon root of x square minus 5x plus 6. X plus 1 is the polynomial function, the whose domain is R. So that leave it now, no problem, x plus 1. So we need to check, this will be 1 by root of x square minus 5x plus 6. That will be 1 by root of g of x. G of x greater than or equal to 0. So that means x square minus 5x plus 6 greater than 0, not equal to 0. So let us see 48 solution. 48 solution. Actually f of x is x plus 1 upon root over x square minus 5x plus 6. Actually this is the quotient function. Quotient function means f of x by g of x or root g of x also, no problem. So here domain of, write down here, domain of x plus 1, numerator. The domain of x plus 1 is R, set of real numbers. So now this domain you need to a domain of x square minus 5x plus 6 root you need to find out, but it should not be equal to 0. That's why for domain the x square minus 5x plus 6 greater than 0. So now factorization I will write x minus 2 into x minus 3 is greater than 0. Left hand side equate to 0. Left hand side LHS equated to 0. So that means we get x minus 2 into x minus 3 equals to 0. So we get critical points. X is equal to 2 or 3 are the critical points. So let us draw the number line now. So take the number line. Okay. This is negative infinity. This is positive infinity. This will be 2. This will be 3. Now wavy curve method. See here x minus 3 power is odd, but moreover whatever it may be, we need to start with plus sign here. X minus 3 power is odd, so negative changes to minus. Now x minus 2 power is actually here odd, so negative changes to positive. So greater than 0 means we need to consider here to here, and next, sorry, positive, here to here we need to consider, but 3 is not included. 3 is not included. You put this symbol. 3 is not included, 2 is not included. So therefore we need to write this domain of f is equal to, domain of f equals to minus infinity comma 2. Okay, one set, and next other set is 3 to infinity. Union you need to write. Union open 3 to infinity. So which is the right option now in this one? The fourth option is the right option. Fourth option is the right option. Forty-ninth question. 49th. The domain of the function thank you, everybody is correct. F of x equals to log of 18x minus x square minus 77 to the base 3 is first option open 7 comma 11, second option open 7 comma 10 open, third is 8 comma 11, both are open, both sides. Fourth option is 8 comma 11, 8 comma 10. Thank you, Ajay Babu. Thank you. The domain of the function f of x is equal to log of 18x minus x square minus 77 to the base 3. So we need to find out. So that means, let me explain the concept. See, domain of log g of x, for example, function is like this, is solution set of g of x greater than 0. This is the basic fact you need to remember. So that's why the domain of this function is log of 18x minus x square minus 77. This is g of x. G of x must be actually greater than 0. Solution for domain, for df, domain of the function f, this 18x minus x square minus 77 greater than 0. Here we need to make x square coefficient positive. Multiply both sides with -1. So what do you get now here? X square minus 18x plus 77 is less than 0. So now write down the 77 factors we can write. This is 77 is factors we can write. Minus 11 into minus 7. Minus 11 plus minus 7 is minus 18. This we can write like this. X minus 7 into x minus 11 is less than 0. So let us find out the critical points now. What are the critical points here? X minus 7 into x minus 11 is equated to 0. LHS is equated to 0. X is equal to 7 or 11. Now take the number line now with the help of number line. Okay, this is negative infinity. This is positive infinity. 7. This is 11. So now the 3 intervals. 1, 2, 3. So now here positive sign. X minus 11 power is odd. Changes to minus. X minus 7 power is actually odd, minus changes to plus. We require only negative. Negative is in between here to here. That means you remember here, now O is not equal to 0, less than symbol. That's why it is open bracket. This also open, both sides open you need to write. That's why now domain of f is equal to, we can write 7 comma 11 open open. That means first option is the correct option. Wonderful. Chalmaya, Swati, Vaibhav, Suma, Sanjha, Mahendra, Sudha, Mahendra, Suma. Okay, wonderful. Vaishnavi, Vinayaki, Prudvi. Oh, Sudha, Suma. Right, everybody. Ashwa Reddy also, Kutturu Pushpa. Right. I hope you might have understood. Okay, Suma, you are correct. Don't worry. But only don't worry about the symbols. 50. Question number 50. Yes, correct, Karthik. Question number 50. The domain of f of x equals to log phi to the base x. Log phi to the base x. I think today evening or day after tomorrow. Don't worry. Be confident. Be positive, Mr. Srinivas Rao. Log phi to the base x is, first one is 0 to infinity, second one is r plus positive real numbers except 1, third real numbers except 1, fourth option is open 0 comma 5. Okay, Vikas. Right. The domain of the function f of x log phi to the base x. So base x must be actually the, let us have a discussion for the base. I will explain. Let me explain. For example, y is equal to something log a to the base x. For example, log a to the base x is a logarithmic function. You remember the base must be like this. X may be greater than 1 or x lies in between 0 and 1. If x is the base, x must be greater than 1 or base may be greater than 1 or base lies between 0 and 1. So that means actually what do you mean by this one? X takes all the positive values and also lies in between 0 to 1, but it's not equal to 0 and it's not equal to 1. That means the domain we can write x greater than 1, or you can write like this 0 comma 1. This can be written like this also, 0 comma 1 union 1 to infinity. Always base of the logarithm will be lies in this one, 0 comma 1 union 1 to infinity. That means except 1, 0 to infinity. Or we can write like this, 0 to infinity minus element of 1. This 0 to infinity is known as actually here positive real numbers. All positive real numbers itself only. That's why second option is the right option. So now write down here domain of f. Domain of f is equal to 0 comma 1 union 1 to infinity. This also correct answer. Sometimes this answer may be there. Sometimes this answer also may be there. 0 comma infinity minus only one element. 0 comma infinity is nothing but set of positive real numbers minus 1. So here we have the answer 2. Second option is the Right option. Fifty-one. 51. Right. 51. The domain of f of x equals to sec 5x is sec 5x is first option set of real numbers minus n pi comma n belongs to set of natural numbers. Second one, set of real numbers minus 2n plus 1 pi by 2 comma n belongs to integers z. Third option, set of real numbers minus n pi by 5 n belongs to set of integers. Fourth option, set of real numbers minus 2n plus 1 pi by 10 n belongs to z. Okay. The domain of f of x is equal to secant x of 5x. See, now here you remember secant x is not defined for x equals to 2n plus 1 pi by 2 values. N belongs to z. So that means if x is the odd multiple of pi by 2, then secant x is not defined. Other than x is equal to odd multiples of pi by 2, the value of secant x is defined. That means it will accept the input values of secant x will be except to a odd multiple of pi by 2. Odd multiple of pi by 2 means pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2 and like that. So that is the general form of the odd number is 2n plus 1. So except 2n plus 1 pi by 2, rest of the thing it's will be valid. That's why now using this basic fact we can write like this. Secant 5x, that is f of x is not defined when 5x equals to odd multiples of pi by 2. Now x value find out. X is equal to, multiply both sides with 1 by 5 also, 2n plus 1 pi by 10. That's why except these values, rest of the values will be valid. That means domain of f is equal to, we can write set of all real numbers, but except it won't accept these values, need to be subtracted. 2n plus 1 pi by 10, n belongs to z. This is the answer. Yes, absolutely correct. Fourth option is the right option. Okay, after completion of this one I will continue the vectors. Right. Right. Madhuri, first concentrate on this one. Fifty-two. the domain of the domain of the domain of okay, f of x equals to cube root x multiplied by cot x, or 2 3 x cube root x times cot x is first option r minus 0, second option set of positive real numbers, third set of positive real numbers, third real numbers minus x such that x belongs to x equals to n pi, where n belongs to natural numbers. No problem, integers are natural numbers. Okay, fourth one, set of real numbers. It accepts all set of real numbers. But actually here we have the product of two functions. First function is cube root of x. Second function is the cot x function. We first actually, the domain of the product function is equal to intersection of the domains of these two. Cube root of x is actually defined for our set of real numbers. That means first write down here. So let us write basic facts here. First fact. What is the first fact means? Domain of say cube root of x is equal to set of all real numbers. This is one fact. So other fact, in order to define the domain of cot x function, so cot x function is not defined, cot x is not defined for x is equal to 0, pi, 2 pi, 3 pi, 4 pi, like that, n pi, n belongs to n or j. So that means actually what we need to write, except x is equal to n pi, the x accepts any value here. So now let us write a solution. Since cot x is not defined at x is equal to n pi, n belongs to n or z. Okay, so that means now the domain of f is equal to, here already real number, domain of accepts real number, but it does not accept x is equal to n pi. Indirectly here x should not be equal to n pi. So we need to delete n pi from the real number system. So that means r minus x such that x is equal to n pi, n belongs to there, n is there, no problem. So third option is the right option. Third option is the right option. '53. The domain of f of x equals to Sine inverse 5x is sine inverse x. Yes, Ritvik Swai. Now I don't start. After that I will start. After completion of this one, because I have promised it to all the viewers such that I may complete the syllabus of Eamcet. After that I will go for that one. First one, minus 1 upon 5 comma 1 upon 5. Second, minus 1 upon 5 comma 1 upon 5. Both sides are closed. Third one, closed minus 1 comma 1. Fourth one, minus pi by 2 comma pi by 2. So before going to discuss about this problem, domain of f of x equals to sine inverse of 5x. First, sine inverse x domain of sine inverse x. Domain of sine inverse x is closed minus 1 comma 1. You remember that means x takes values minus 1 comma 1 because the range of sine x is minus 1 comma 1. The range of sine inverse x becomes the domain of sine inverse x. So that is, we can write like this also, minus 1 less than or equal to x, x less than or equal to 1. That means domain of x is lies between minus 1 comma 1, but here actually we have 5x. So as for this basic fact, 5x should lie between minus 1 comma 1. So that means now for domain of f we have this minus 1 less than or equal to 5x, 5x less than or equal to 1. So then divide throughout by positive 5. That means plus 5. So if you divide by plus 5, inequality symbol will not change. So minus 1 upon 5 less than or equal to x, x less than or equal to 1 by 5. That means x lies between minus 1 comma 1 by comma 1 upon 5 comma 1 by 5. Therefore, domain of f is equal to minus 1 by 5 comma 1 by 5. Here equality is there. So closed both sides. That means second option is the right option. Option 1, 2, 3, 4. 1, 3, 4. Okay, can you solve this question? Domain of f of x by 1 by root of x minus 1 by root of 1 minus x square. So I don't have the idea, Padma. I will check it now. I will check it. If you know the method, actually you can forward it. No problem. Fifty-four. 54th problem. The domain of f of x equals to mod of x minus 2 plus mod of x minus 5 is the domain of f of x equals to mod of x minus 2 plus mod of x minus 5 is first option r minus 2 comma 5, second one set of real numbers 0 minus 0. Third option, set of positive real numbers 0 to infinity. Fourth one is set of real numbers, total real number system. Okay, let me discuss the first actually concept, basic facts. What are the basic facts means? Domain of mod x is set of real number system, or the domain of mod of x plus or minus a is also set of real numbers, or here provided whatever it may be, a belongs to real numbers, set of real numbers. So that means domain of x mod x is also or domain of x plus a, x minus a. That means here this is a sum function. The first function, this is second function. Domain of the first function is also R. Domain of the second function is also R. R intersection R is R only. So that means you write down like this solution. Let us say this function is g of x, mod of x minus 2. H of x is mod of x minus 5. Say d1 is the domain of g equals to set of real numbers. d2 domain of h function is also R. It takes all the real numbers. Therefore, domain of f we need to find out. Domain of f is equal, because it's a sum function, so the domain will be d1 intersection d2. So both sets are equal sets. The intersection will be R only. R intersection R is R, set of all real numbers. So fourth option is the right option. Okay, understood all of you? I hope. Okay. Fifty-five. The domain of f of x equals to root over x minus 1 upon 2 minus x is (930 to 1130). First option is open, 1, 2 open. Second option 0, 2 both are open. Third option is closed, 1, 2 open. Fourth, here closed, 1, 2 closed. This is the question, right? Domain of f of x is equal to root of x minus 1 upon 2 minus x is. This will be in the form of, actually we have domain of root g of x is solution set of g of x greater than or equal to 0. And one more condition here, the 2 minus x does not equal to 0. This condition to be satisfied. 2 minus x does not equal to 0. That means x should not be equal to 2. So you keep these basic facts. Okay, let us do it now. So now the solution, x minus 1 upon 2 minus x is greater than or equal to 0, but x does not equal to 2. You remember this condition. Next, multiply both numerator and denominator with 2 minus x. You get x minus 1 into 2 minus x upon 2 minus x whole square greater than or equal to 0. Cross multiplication takes place. By cross multiplication, x minus 1 into 2 minus x is greater than or equal to 2 minus x square is the positive value into 0, 0. So to make x coefficient positive, multiply with the negative sign. X minus 1 into x minus 2 is less than or equal to 0. So understood now. So that means actually here see the points, critical points are x is equal to 1 and 2. These are the critical points. Take a number line now. Number line. Here 1, this will be 2. Okay, I will write directly. This is plus sign, this is minus sign, this is plus sign. Less than and equal. Less than equal, but one condition is there. What is the condition actually here? X does not equal to 2. This must be remembered. So that means actually here 2 is open, but whereas 1 is closed. 1 is closed. And 1 to 2 you need to consider. Therefore, domain of f equals to closed 1 comma 2 open. So that means third option is the right option. Third option is the right option. So here also I applied the wavy curve method. So not curvy, that is wave curve method. Sorry. This method is called wave curve method. Okay, I will check, wait. One minute. Yes, Suma. Okay, now the question number 56. Question number 56. The domain of okay. The domain of f of x equals to root of x minus 1 x plus 1 times x plus 2 is first option open minus 2 comma minus 1 union open 1 comma infinity. That means actually minus 2 comma is not included, minus 1 is not included. only the set of real numbers lies between -2 comma -1 is here included. Union 1 to infinity means 1 is not included. From in between 1 to infinity, all the real numbers will be included. That is the meaning of open and closed. The second one, closed -2 comma -1. That means -2 is included, -1 is included. In between them are also included. Union closed 1 to infinity. Third one, closed -2 comma -1. Fourth is open 1 to infinity. Okay, understood now? So the domain of f of x equals to root of x minus 1 times x plus 1 times x plus 2. So this will be basic facts. The domain of root g of x is the solution set of inequality g of x greater than or equal to 0. This is the basic fact. Okay. So now solution for a domain of f, x minus 1 times x minus plus 1 times x plus 2 times greater than or equal to 0. Now we need to apply wavy curve method. Means actually left hand side equated to 0. LHS equal to 0 for critical points. You get critical points like this. X is equal to -2, -1 and 1. So let us draw the diagram here. Okay. So now number line. So -2 is less than -1. After that -1, arrange ascending order 1. Now intervals 1, 2, 3, 4 intervals. This is positive infinity, this is negative infinity, this is positive infinity. Okay, sign scheme. Sign scheme is we need to follow like this sign scheme. So what is the sign scheme here? This is plus, okay, odd power, minus, this also odd power, plus changes to minus. But greater than or equal. Greater than equal means we need to consider positive sign here to here and here to here. And what we need to do, we need to include this 2, just round it. -1 is also included and also 1 to infinity is included. So now we need to write the domain. See the domain of the required function. Domain of f is equal to 2 is included, closed -2 comma -1 included, -1 union, because union closed 1 to infinity. Understood all of you? It is very important. Okay, so that means this is the second option. Now you got it. Yes. Thank you. 57th question. 57th. The domain of f of x equals to 1 upon root of x minus 1, x minus 2, x minus 3 is okay. First option minus infinity comma 1 union 3 to infinity. Second option 1 comma 2 both are open union open 3 to infinity. Third option minus infinity comma 2. Fourth option all set of real values. Okay. Domain of f of x equals to 1 by root of x minus 1 times x minus 2 times x minus 3. That means actually here the basic facts we need to discuss. Domain of 1 upon root of g of x is solution set of g of x greater than 0 not equal to 0. That means actually solution here x minus 1 times x minus 2 times x minus 3 times must be greater than 0 not equal to 0 greater than 0. So that means now the critical points right. Critical points means x is equal to 1 2 3 because if you equate LHS equal to 0 we get critical points. Now draw the number line. That means wavy curve method. Okay. This is 1, this is 2, this is 3. 1, 2, 3. Now sign scheme. Plus sign start with the right hand side minus plus minus. Greater than 0 means we need to consider positive. So here to here. But actually what happens now here? 1 is not included, just only round bracket, not shaded totally. So therefore domain of f equals to, we can write 1 comma 2 both are open union open 3 to infinity, because this is positive infinity, this is negative infinity on a number line. I hope everybody understand. Right. Okay. Any new viewers are there, you need to subscribe and share to your friends. Okay. Right. 58. The domain of f of x equals to root of x minus 3 upon x plus 3 plus root of 2 minus x upon 2 plus x is First option minus infinity to 2 union 3 to infinity. Second option 2 comma 3. Third one is set of all real numbers. Fourth one is nothing, null set pi. Right, let us see. Here actually sum of the two functions. Let us find out the domain of first function, say d1, domain of the second function, say d2. d1 intersection d2 we need to find out. So okay, first let us find out here. Solution. For the first function, x minus 3 upon x plus 3 is greater than or equal to 0. X minus 3 multiplied by x plus 3 upon x plus 3 whole square greater than or equal to 0, and also you can write that implies x minus 3 into x plus 3 greater than or equal to 0, but x plus 3 does not equal to 0. That means x does not equal to minus 3. So now we need to write, take a number line, okay. So critical points are here minus 3 and 3. Now directly we can write, everybody will understand. This is plus, minus, plus. So you need to consider plus sign means here to here and here to here. This is not included, just put the open bracket like this. But here 3 will be included, you shade it like this. So now say domain d1. d1 equals to, we can write minus infinity to minus 3 open union 3 to infinity. For this one, let us go for second function. For second function, 2 minus x upon 2 plus x is greater than or equal to 0. Multiply both numerator and denominator of left hand side with 2 plus x. What do you get now? 2 minus x into 2 plus x upon 2 plus x whole square greater than or equal to 0. And we get 2 minus x into 2 plus x greater than or equal to 0, but x does not equal to minus 2. Because actually if you multiply minus x into plus x minus x square, multiply minus 1 on both sides, you get x minus 2 into x plus 2 less than or equal to 0, and x does not equal to minus 2. So now take a number line here. Here critical points are minus 2 and 2. Here 3 intervals. Take the sign. This will be plus sign, this will be minus sign, this will be plus sign. Less than 0, here to here we need to consider. And next, x does not equal to minus 2, just only. Now 2 is included. 2 is included means you shade it now like this. Here d2 is equal to, we can write minus 2 open comma 2, this one. So now we need to find out 3 is included. Yes, 3. No, yes, 3 is included. It's correct. 3 is included. Minus 3 is excluded. 3 is included. Right, absolutely correct. 3 is included. Yes. So now d1 intersection d2 we need to find out. This is domain of f. That implies, take the number line again. Take the number line. First critical point of the first minus 3 3 and minus 2 2 you need to write. First minus 3 minus 2 2 and 3 write down. So first solution you need to shade. What is the first solution? Here we have minus infinity to minus 3, minus infinity to minus 3. Here this is minus infinity, so this is not included. Next 3 to positive infinity, here to here 3 is included, right? So next now minus 2 to 2, minus 2 to 2, minus 2 to 2. Okay, minus 2 to 2 means here and here. So now here 2 is included, this is not included. Intersection, no common part we can find out here. That's why therefore domain of f is equal to nothing, null set. So pi is the solution. Fourth option is the right option. Fourth option is the right option. $59. Correct. Question number is 59. Okay. 59. Yes, Kodala, you are absolutely correct. The domain of f of x equals to f of x is equal to 1 upon root over x minus x square plus root over 3x minus 1 2x square is. Actually one of the viewers asked me this question, this type of question, but whether he is there or not I don't know, or you might be watching offline, I don't know. But you need to stay till the completion of all the models, those who asked the questions. So closed of comma 1, second question, closed of comma 1 open, third open 1 by 2 comma 1 closed, fourth one open 1 by 2 comma 1 open, right? So these type of questions are very important, because actually we need to do we need to find out the domain of the first function and domain of the second function and their intersection we need to find out, just like in the previous problem, 50th problem. Okay, it might be of comma 1, let us check it now. I don't have the idea whether of comma 1 or of comma 1, whatever. See, I go for the solution now. First we need to find out the domain of this one function and domain of this function. Say domain of this function is d1, is d2. Our plan is d1 intersection d2 is our plan. Okay, right. 59 solution. 59 solution. First let us say g of x equals to 1 by root of x minus x square. Here x minus x square should be greater than 0. Multiply with minus sign, x square minus x less than 0. Take x common, x into x minus 1 less than 0. Okay. x into x minus 1 less than 0 means take the number line, wavy curve method, x is equal to 0, critical point 1. Okay, this is plus sign, this is minus sign, this is plus sign. So now you need to consider here to here, 0 is not included and 1 is not included. So that means actually d1 equal to domain of G equal to, we can write open 0 comma 1. We got one solution only. Right. Next, let us say other function h of x, you say, that will be root of 3x minus 1 minus 2x square. For this one, 3x minus 1 minus 2x square must be greater than or equal to 0. Okay. Now, multiply with minus sign, you get 2x square minus 3x plus 1 greater than or equal to 0. The middle term can be split like this, minus 2x minus x plus 1 greater than or equal to 0. 2x common, we have x minus 1, and minus 1 common, we have x minus 1 greater than or equal to 0. So we get x minus 1 multiplied by 2x minus 1 greater than or equal to 0. Understood now? Okay, next now critical points. Critical points, actually here we have 1 by 2 and 1. So now number line, this will be 1 by 2, this will be 1. Okay, this will be 1. Here plus sign, minus sign and plus sign. So what we need to consider, plus greater than 0 means here to here and here to here. So we need to consider this one. This is closed. But already actually see in this case 1 is not included. Just open up, no problem here. Or close it, no problem also. It's also closed. So what is the D2 here? D2 equals to, we can write domain of H equals to minus infinity comma 1 by 2 closed union, so 1 to infinity. So now domain of F equal to D1 intersection D2 we need to find out. D1 intersection D2 we need to find out. Okay. Right. Here sign we need to change it now. Wait for a while. It's a very important thing actually. If you multiply minus sign, the symbol reverses. Less than 0, less than 0, less than 0, less than or equal to 0. Sorry, less than or equal to 0. So that means actually here you take the number line now. Yes, अब गलत हो गया. Minus infinity plus infinity. This will be 1 by 2. Absolutely correct. We should be very careful. Right. Now wavy curve method, plus sign, minus sign and plus sign. So less than means we need to consider here to here, and this is included and this is included. Am I correct now? So that's why domain D2 equals to domain of H. So that is 1 by 2 comma 1, both sides open. Right. Now we need to find out d1 intersection d2. df equals to d1 intersection d2. Right. So now take the number line. First locate the critical points. This is negative infinity. This is positive infinity. 0. What are the values we have here? 1, 1 by 2. 1 and next 1 by 2. 1 by 2 is here. Okay. Any more values? Yes, 1, 1 by 2. That's all. Now let us shade it. 0, comma 1. 0, comma 1. Here to here. 0, comma 1. 0, comma 1. This is now, we check it now, this one half comma 1. Half comma 1. Half comma 1. So this is the intersection part. This part we need to consider. But it's clear, half is included, 1 is not included. 1 is not included. So therefore domain of f is equal to, we can write. So here closed half comma 1 open. This is the answer. Second option is the right option. Second option is the right option. Right. Right. Problem number 60. Problem number 60. Problem number 60. Okay, I will be coming. Kodala Kalyani. Okay. The domain of the real valued function. Real valued function means real valued function f of x equals to root over 25 minus 9x square plus root of x square plus x plus 1 is. What do you mean by the real valued function? Anybody? Okay, Raghuram. Tomorrow I will start areas. Granted, take it granted. The real valued function means the range of the function is the subset of the real number system. Right. So the domain of the real valued function f of x is equal to root of 25 minus 9x square plus root of x square plus x plus 1 is. Yes. So that means actually first, in order to find out the domain of this function, the domain of the real valued function f of x is equal to root of 25 minus 9x square plus root of x square plus x plus 1 is. So first option minus 5 upon 3 comma 5 upon 3 open bracket Second, minus 5 upon 3, comma 5 upon 3, closed. Third option, minus infinity to minus 5 by 3, open, union, closed, 5 by 3, comma infinity. Fourth option, minus infinity, comma minus 5 upon 3, union, open, 5 by 3, comma infinity. This is the question. Don't ask such question, Mahindra, because shall I stop the class now? Right. So that means first domain of this function, we need to find out the domain of this function, intersection of these two. So okay, now 60 solution. Let us say first g of x equals to root over 25 minus 9x square. This is just like a square minus x square only. A square minus x square means actually closed minus a comma a. Yesterday we have discussed. Understood now? That means we can write like this also. 25 minus 9x square should be greater than or equal to 0. Multiply with minus sign. 9x square minus 25 less than or equal to 0. This can be written 3x plus 5 into 3x minus 5 less than or equal to 0. See, now take the number line. Locate the critical points. What are the critical points? Minus 5 by 3 and 5 by 3. This will be minus 5 by 3 and this will be plus 5 by 3. Okay. This is plus sign. This is minus. This is plus sign. Less than 0 means we need to consider this part. This is included and this is included. So D1 equals to closed minus 5 by 3 comma 5 by 3. Okay, let us come to the second function. Second function. What is the second function? We have very interesting here. Second function is, let us say h of x, that is root over x square plus x plus 1. So we need to find out, since it is in the form of root of g of x should be greater than or equal to 0. X square plus x plus 1 greater than or equal to 0. So that means we cannot find out the factors. You check discriminant d value, b square minus 4ac. b square minus 4ac means actually 1 square minus 4. 1 minus 4 minus 3 is less than 0. That implies roots of LHS is equal to 0. X square plus x plus 1 is equal to 0 or imaginary. Imaginary. We have one theorem. What is the theorem? If the roots of ax square plus bx plus c is equal to 0 are imaginary, x square plus x plus 1 and ax square plus bx plus c and x square coefficient will have the same sign for every x belongs to R. So that means here x square coefficient write down. X square coefficient is equal to 1. 1 is greater than 0. That expression also greater than 0. It happens only for every x belongs to real numbers, set of real numbers. That means domain. domain of this function d2. d2 is equal to set of real numbers. Now the domain of f is equal to d1 intersection d2. d1 intersection d2 means d1 is the subset of d2. Am I correct now? d1 is the subset of real number system. That's why if d1 is the subset of d2, d1 intersection d2 is equal to d1. That's why closed minus 5 by 3 comma 5 by 3. This is the required or desired answer. Understood now? I think repeat the theorem. Okay, I will repeat the theorem. If ax square plus bx plus c is equal to 0 has imaginary roots or equal roots, then ax square plus bx plus c expression and x square coefficient a will have same sign. The theorem from the quadratic expressions. First theorem. Yes, I hope you might have understood this one. So Kodala Kalyani, you asked this type of question. So this question is the actually answer for you. Right. Sixty-one. Capital A is the domain of f of x equals to 1 upon root of mod x minus x, and the domain of g of x is equal to root over 1 minus mod x. Then A intersection B. We are asked A intersection B. Intersection of the domain of the first function and domain of the second function. First option minus 1 comma 0. Second option closed minus 1 comma 0 open. Third minus 1 comma 1. Fourth closed minus 1 comma 1. Right. So let us find out the domain of f of x and g of x. Okay. Right. Here I have forgotten. I need to write like this. Excuse me. And B is the, I need to specify. Am I correct now? Okay, first let us find out the domain of A. For domain of A, the mod x minus x must be greater than 0. So mod x is greater than x. See, so mod x minus x, yes, mod x minus x is greater than 0. Right. So mod x is always greater than x. Mod x will be, because if you take any value, for example, even x is equal to mod x equals to, mod x means actually for every, you can write x belongs to any value r minus 0. Am I correct now? Except 0, r minus 0. Next, this is the now the domain A equals to, we can write like this: x such that x belongs to set of real numbers minus 0. This mod x will be x less than 0. How it is correct? X less than 0. No. Right. Now, for the second one, 1 minus mod x must be greater than or equal to 0. So multiply with minus sign. Mod x minus 1 less than or equal to 1. Mod x will be less than or equal to 1. Less than or equal to 1. Right. So that's why now here one more thing also, 0 comma 1 also here you need to write. Zero comma 1. 1 also will not satisfy because mod 1 is 1, 1 minus 1 becomes 0. Okay, right. Zero comma 1. Now the mod x is less than 1. That means we can write minus 1 less than or equal to x, x less than or equal to 1. So that means actually what happens now here, it takes all the intersection of these two we need to write. B equals to this one, B equals to, this is closed minus 1 comma 1. Now we need to find out A intersection B. A intersection B we need to find out. Take the number line. This is minus infinity. This is positive infinity. 0. So minus 1 and 1. So now what we need to write now here? So minus 1 to 1. Here to here. And next this will be except 0 comma 1, all the real values. All the real values. Except 0 and 1. All the real values. That means you shade like this. Okay. So that means A intersection B is equal to, we can write like this: minus 1 to 0 closed union 0 comma 1. This is the answer. This is the answer. Okay, 0 comma 1. Even 1 is not also included. 1 is also not included, I think. Yes. 1 is not included. Yes, 0 comma 1. Union 0 comma 1. Now, what do you mean by this one? Minus 1 comma 0 is there and 0 comma 1. 0 comma 1 is not there. Yes, now we can take second option is the correct option. You can take it. Right. 62, 62, 62. The domain of f of x equals to root of x square minus 4 mod x plus 3 is first option minus infinity comma 3, second closed 1 to infinity, third minus infinity comma minus 3 closed, union closed minus 1 to infinity, fourth option minus infinity to minus 3 union minus 1 to 1 union 3 to infinity, 3 to infinity, right. So now the x square minus 4 mod x plus 3 greater than or equal to 0 to define the domain of f. This can be written mod x whole square 3 mod x minus mod x plus 3 greater than or equal to 0. So mod x common, we have mod x minus 3. So minus 1 common. So minus 1 common, mod x minus 3 greater than or equal to 0. So now the mod x minus 3, we can write mod x minus 1 greater than or equal to 0. So we can write now here mod x is less than or equal to 1, or we get mod x is greater than, less than or equal to 1 or greater than or equal to 3. Mod x less than 1 means minus 1 less than or equal to x, x less than or equal to 1. Or we can write mod x greater than 3 means x is greater than minus 3 equal to minus 3, or x is greater than or equal to, sorry, x is less than or equal to 3. X is less than or equal to 3. That means we need to write all these solutions. All these solutions means actually here see x less than or equal to x less than or equal to 3. Wait, I did mistake here. So that means actually mod x greater than or equal to 3 means x is less than or equal to minus 3, or x is greater than or equal to 3. Write down all the intervals. Now domain of f is equal to x is less than minus 3 means minus infinity to minus 3 closed union, next this one write down closed minus 1 comma 1 union closed 3 to infinity. That means fourth option is the right option. Fourth option is the right option. Fourth option is the right option. Okay, next. 63. 63. Domain of f of x equals to 1 upon log mod x is first option r minus -1 comma 0 comma 1, second one r minus 0, third one r minus -1 comma 1, fourth one set of real numbers r. So now domain of f of x is equal to 1 by log mod x. 1 by log mod x means here conditions you see, log mod x should not be equal to 0. One condition. Log mod x should not be equal to 0. That means mod x should not be equal to, for example, e to the power of 0 is equal to 1. That means x does not equal to plus or minus 1. One case. Second fact, basic fact is x should not be equal to 0. That means here we can conclude that x does not belongs to -1 comma 0 comma 1. Except these three values, any value it will accept the input values. That's why domain of f is equal to set of real numbers minus -1 comma 0 comma 1. That's answer. So that's why first option is the right option. Right. So actually we learn the mathematics from the mistakes. Everybody will do the mistakes. So we need to do the mistakes, then only we will correct ourselves, we will update ourselves. So that is the actually tendency of the mathematics. The mathematics can be learnt through the mistakes only. Please, my dear children or students, remember like that. So, but you need to rectify it. So we need to rectify ourselves. Then we will update ourselves. Thank you. Why not 0? Why not 0 means actually if you put 0, log 0 is not defined. Log 0 is not defined. Is not defined. Right. '64. 64th question. Domain of f of x equals to root of log x to the base a. Here a greater than 1. Base very important. That need to be yes. A greater than 1. First option is 0 comma 1. Second option closed 0 comma 1. Third option closed 1 to infinity. Fourth open 1 to infinity. This is the question. Solution. Right. Here see, to define a domain, log x to the base a should be greater than or equal to 0. Greater than or equal to 0. So that means now we need to apply the inequality concept on this. We can write log x to the base a greater than or equal to, we can write log 1 to the base a. Therefore x must be greater than or equal to 1. X must be greater than or equal to 1 means domain of f is equal to closed 1 to infinity. So third option is the right option. 65. The domain of f of x equals to log of root over 4 minus x square upon 1 plus x is see the first option is minus 2 comma 2, second option minus 1 to infinity, third option closed minus 1 comma 2, who is Kalyani? Okay, right. Now the solution. See, for the domain of f of x, the root of root of 4 minus x square defined only when, here see, 4 minus x square is greater than 0 itself only, not equal to 0 also. If it becomes 0, log 0 is not defined. Understood now? So that's why 4 minus x square must be greater than 0. That's why x square minus 4 we can write here less than 0. So x plus 2 into x minus 2 is less than 0. So that means actually here x belongs to, directly we can write minus 2 comma 2. This is this solution. Say equation 1 this is. Next, this 1 plus x must be positive. 1 plus x must be positive. That means 1 plus x must be greater than 0. That means x must be greater than minus 1. That means x belongs to here open minus 1 to infinity. Say equation 2 now. Intersection of 1 and 2 we need to find out. 1 intersection 2 we need to find out. So take a number line now. Take a number line. On a number line, let us locate the critical points. What are the critical points here? We have minus 2 and minus 1 and we have 2. So intervals. Sorry, not intervals. We need to shade, not wavy curve method. Intersection of 1 and 2 we need to find out. First this solution. See, minus 2 to 2. Minus 2 to 2 we have. Here to here. Minus 2 to 2. This will be minus 1 to infinity. Minus 1 to infinity. This is positive infinity. This is side is negative infinity. Solution is now where to where we have minus 1 to infinity. Minus 1 to infinity. Okay. So now the common part you select it. This is the common shaded area. So that means here to here we need to select the solution. Here 2 is not included. 2 is not included and minus 1 is not included. So domain of f is equal to, we can write open minus 1 comma 2. Fourth option is the right option. Fourth option is the Right option. Am I correct now? All of you. Have you checked, all of you? Generally, everybody will be afraid of these things itself only. If you know all the basic concepts, function is chapter is very easy, and domains and ranges of the function easily we can find out. Then root of a square minus x square, when will we be apply? If it is given directly. Okay. Now the 66th problem. 66th problem. 66th problem. The domain of the function f of x equals to root over log of 1 by mod of sin x. Mod of sin x. Okay. Is first option r minus 0. Actually in offline session also, just you give your suggestions. That will be the better, but that will be online. If you give the online chart, that will be only for few days it will be kept. But if you give offline suggestions also, so that I will update myself, because I can see after all comments, then I will try to update myself and I will modify the even my teaching strategy also. Understood now? So I think you will follow like that. Today onwards, even in offline also, you give suggestions on the comment box, and please share to others also. Like and share. R minus 0 comma pi. Third one, r minus x such that x is equal to n pi, n belongs to integer I or z also symbol you can use, no problem. Yes, today onwards I will check your comments also after completion of this session. That will be the feedback to me. X such that x is equal to 2n pi, n belongs to integer I. Okay. The domain of the function f of x is equal to root of log of 1 by mod sin x. The mod sin x means basically the sin x should not be equal to 0. If sin x is equal to 0, 1 by 0 is not defined. Understood now? That means sin x does not equal to 0. Condition you need to remember here. The sin x does not equal to 0. That means sin x does not equal to sin n pi. X does not equal to n pi. But it takes all the real values except n pi, multiples of pi, 2 pi, 3 pi, 4 pi, and so like that. Therefore now domain is equal to, we can write domain of the function is equal to r minus x such that x is equal to n pi, where n belongs to integer. This answer. Third option is the right option. Right. Good, good, good. Actually, so far I uploaded more than 120 or 130 videos on especially Eamcet 2020 videos only, free math classes. But so far I didn't receive a single comment from the regular viewers. Okay, only offline viewers are only one or two, but don't do like that. You need to give the comments and suggestions, that to be definitely we will follow. So many we have regular volunteers but not coming to the regular the classes. What happened I don't know, but new viewers are there. You are also part and parcel of our YouTube channel. Now here onwards you will be treated as our volunteers itself only. Okay, Ambarish, Balu, option 3. Okay, 67. The domain of f of x equals to log of root over x minus 4 plus root over 6 minus x. Teju Sreya. Oh, very good, very good. Base 10 is first option, open 4 comma 6 open interval, minus infinity to 6 third, 2 comma 3 fourth, minus infinity comma 4. Okay, thank you. Even for other videos also, if you watch offline, please give the comments. Vishwank, yourself also. Balu, our regular viewers are there. Prudvi, Karthik, Chandana Sri, next Suma, Balu, okay, Nitik. So many are there. Domain of f of x equals to log of root of x minus 4 plus root of 6 minus x. So that means root of x minus 4 is defined for x minus 4 greater than or equal to 0. 6 minus x is also greater than or equal to 0. We need to find out intersection of these two. So let us do it now. So to define this log function, this x minus 4 must be greater than or equal to 0. X is greater than or equal to 4. That means x belongs to closed 4 to infinity. This is, say, first. Second part. This 6 minus x is also greater than or equal to 0. So to make Bhumika, yes, you, Bhumika, I couldn't find you. Where had you been? You are also regular, I know. Where about Bilvasri? She had been. She left, I think so. Multiply with minus sign. X minus 6 less than or equal to 0. Dhruvamsh also. X less than or equal to 6. This we can write. So minus infinity to 6. Close. X belongs to, say, 2. Now we need to find out one intersection 2 to get a domain, to get df, domain of the function. Right. Vaibhav Potiri, what's your name? Take the number line. This is negative infinity. This is positive infinity. So critical points is 4 and 6. First 4 to infinity, you shade it. 4 to infinity. 4 to infinity means like this. 4 is included. You shade like this. This symbol included. Okay, Vaibhav. Okay. Next 6 to infinity. You take others. 6 to infinity. This is included. So now 4 to 6. That means we need to write now domain df is equal to closed 4 comma 6 closed. That means first option is the right option. Today, Tejusreya, today IPE results? Yes or no? Now you can chart, no problem. Still we have 5 minutes. You can chart. What about today TS results are going to be announced or no? Okay. 68. Okay. So even for after announcement of the result of Telangana, both AP and Telangana, I will bless you all. Right. No clarity. Leave it. The domain of f of x equals to log of tan inverse x is good morning Nagamani Baggam, where had you been? Just you entered in the dragon. R second, R plus third, 0 to infinity closed, fourth minus pi by 2 comma pi by 2. Right. Here see domain of tan inverse x is minus infinity to infinity or real numbers. But here we have log of tan inverse x. Tan inverse x must be positive, should not be equal to 0. That means actually for domain of f, the tan inverse x function must be greater than 0, positive only. For example, if you take the number line like this is negative infinity, this is positive infinity. Suppose say this is 0. So even this should not be 0 also. One more condition here. Log of tan inverse x only greater than 0 I considered here. So that means tan inverse x greater than 0, positive will be happens only here to here. But here to here it will be negative. Tan inverse x will be negative. As tan inverse x greater than 0, we need to consider this one only. So now here 0 is not included. 0 is not included. Just open up like this. Therefore, domain of the function is equal to open 0 comma infinity. This is called non-zero real numbers. Non-zero real numbers. Thank you, Shruti Reddy. Subscribe first of all. So non-zero real numbers means you can write positive real numbers, R plus. So second option is the right option. Second option is the right option. So thank you one and all. Bye bye. See you. Okay. So we shall meet you in the afternoon session. Evening session. Sorry. Evening session. Thank you. Thank you, Joel. Okay, first today in the offline, all of you put your suggestions. See, today at least I need to see more than 100. So I need to see more than 100 comments should be there. Then I will continue the classes. Thank you.